So, good morning to all. Today we are able to know the structural geology. So, actually, in the earlier class, we learned about the primary structures. So, because of in the igneous rock structures, sedimentary rock structures, metamorphic rock structures. So, those structures will be called as the primary structures. So, in this session, we are able to know secondary structures, namely folds, faults, joints. So, basically, structural geology deals with based on the secondary structures, it will be called as fold, fault, joints, and also it will be deals with that origin and occurrence and classification of different types of folds and faults and joints. So this is about secondary structures. Secondary structures are formed due to the compressional forces. So while be acting under that after formation of rock, so due to compressional forces, the rock will be either bent, either will be displacement. It will be called as either it is a bent, which we call it as a fold, or displacement will be called as a fault. So either be adjacent to that, we call it as a joint. So these are the secondary structures we discuss about to that entire structural geology. So what is the outcrop? So outcrop means any elevation of rock masses, it will be called as outcrop. So this is the outcrop, so exposed within that the surface area, it will be called as outcrop. In the structural geology, there is a key two units is there. One is the strike, another one is the dip. So what is the strike? A strike is a line. It's a measure for some direction, intersection of bedding plane and horizontal plane. So if you seen into that, so this is the strike line. So this is the strike line. So intersection between horizontal plane and bedding plane, we call it as a strike. And dip is always perpendicular to the strike. So which are the downward movement will be slope is there, it will be called as a dip amount. So strike and dip will be measured for, so in the any outcrop area, how much of amount is there, how much of incline is there. So we are able to find out to that the particular area of direction and the amount of rock masses. It will be calculated as a strike and dip. So present day we are utilizing to that, and the clinometer and different types of material will be using for measure for direction and dip direction. But earlier days, those who are not available for any type of instruments, so those people are utilizing for a glass of water to throw into that particular rock area. Whichever the material will be down for to that will be direction will be called as a dip direction. The opposite will be called it as the strike direction. So that will be earlier days the people will be utilized. So nowadays we are utilizing for clinometers and different type of compass meters will be utilizing for measuring of strike and dip. So this is about the dip. So dip always is a perpendicular to the strike. So it will be inclination to that downward movement. So these are the so different phases of strike and dip. The how will be calculated as in that field area. Now coming to that secondary structures, that is the secondary structure mainly the one of the topic is the fold. So what is the fold? So fold is the undulation of rock strata. It will be bent upward or downward. It will be called as a fold. So if you see, so due to compressional forces, so the rock area will be either due to compressional forces, the rock will be bent, so it will be undulation of rock strata. It will be subjected to that is the concave side is that convex side is that called as anticline. So this will be called as syncline. So those anticline and synclines formed as due to compressional forces acted on the particular rock body. The rock body either bend with a downward, either bend with one upward. It will be called as anticline and syncline. So this is the showing to that the fold and fault. See how the beauty of in geology. So if you seen into that, the rock masses again will be observed different types of layers. You are able to see. So this is the concave. So this is the convex. So when you cutting the any roads, these type of structures will be identified. So in that whether it is the working in the tunnel engineering or any other construction will be constructed by in the rocky areas, it will be these types of structures we will see into that identification of faults. So the parts of faults, in the faults have different types of parts is there. So that is called as axial plane. So faults have different types of faults. So that will be called as axial plane. Axial plane is the imaginary line. So when cutting into that any fold, in that exact center point we call it as a axial plane. So in that vertical we call it as axial plane, the horizontal we call it as hinge line. So both places we call it as, both edges we call it as a limbs. So this is about the limbs. So when the exact center point we call it as a axial plane. Axial plane is the imaginary line. Our hinge line also is the imaginary line. So both, so number of zones will be identified in the hinge planes. It will be called hinge zone. So both edges we call it as limb. The center point we call it as axial plane. So these are the parts of the fold. So based on the limb direction and axial plane direction, limb inclinations and axial plane directions, folds are divided into different parts. So now classification and types of folds. So anticline and syncline is that part of the fold. So due to compressional forces acted on to that particular rock body, so that we call it as, it will be called it as an anticline, it will be called it as syncline. So this is the anticline structure. So this is the syncline structures. So in the anticline structures, older beds are in that inner side. So in the syncline structure, younger beds are this side. So these are the older bedders. So these are the younger bedders. So younger beds are formed in the center, the older beds are formed in the center in the anticline structure. In the syncline structure, the recent sediments, recent beds will be formed as in that this particular side. So this is we call it as a anticline structure and syncline structure. So these are the one type of fold while we seen into that in the field area. So see, this is the syncline and anticline. So if you see earlier we seen into that those textures in the diagram very quickly, but always the beds will be in the syncline structures. These are the younger beds we already seen. So these anticline structures, older beds are will be center. So that will be differentiated to that anticline and syncline. So these are the, in the one particular view we are observed to that anticline and syncline. So if you see into that anticline directions, if you cross section to the different hinge lines, we are able to identify the different types of limbs at the same time we have to see into that syncline structure. So in the limbs will be always the towards to that each in that convex side is the away from the each other, in the concave side is the towards to each other. So this is about to that showing to that anticline and syncline structure in that different rock masses. Anticline and syncline due to compressional forces acted on the syncline to that. So in the entire in the geological formation we are able to see so these type of structure anticline wise. So these is the real examples of different materials we will shown into that anticline and syncline structures. And symmetrical and asymmetrical flow. So symmetrical means it means exact two equal halves when cut it in the fold. So one image will be always the second image will be mirror image. So when will be symmetry means when you cut it in the any type of fold two equal halves, that we call it as a symmetrical fold. So one image will be always another image a mirror image. Asymmetrical means some inclinations will be identified to that in the particular fold, so that we call it as asymmetrical. So if you have to see different types of folds in the symmetrical and asymmetrical, so we are able to see into that in this particular figure different symmetrical fold. If you observe, symmetrical means one image always in the equal halves. So one image will be always the opposite image will be mirror image. So that we call it as a symmetry. So symmetry means to cut it in the any type of fold to equal faces, we call it as a symmetry. So in the similar scenario, so asymmetry means unequal. So we are unable to see into that asymmetrical fold. So those limbs are the unequal. So if you see in that overturned fold, so the axial plane will be inclined. Always, most probably in the limbs will be always overturned into that fold. So that's we call it as overturned fold. So in this particular image, we are seen into that symmetrical fold and asymmetrical fold and overturned fold. Symmetrical fold means when the fold will be cut into the two equal halves, and the asymmetry means unequal. So overturned means related to that always in the vertical nature. So this is about symmetrical and asymmetrical fold. And open and closed folds. So open and closed folds are so when you see into that open fold, so the entire frame will be equal. So if you see into that always in that open fold, the starting to ending, so in the if you see into that open fold, starting to ending always some equal type of nature is there. So this will be called, this is a different strata. So we are able to identify always, so equal type of proportions will be identified. So when it comes under to that closed fold, the limb side will be in the starting will be very narrow. So in the end of the fold, it will be widthen to that identified, that will be called as a closed fold. So open fold and closed folds are commonly identified in that folds. If you so depends on to that the thickness, the variations will be identified. So in the open fold always a similar thickness will be identified in the entire fold, but in the closed fold in the starting will be thickness will be very less, the end of the fold will be thickness will be increased to that. So that's the difference between open and closed fold. So these are the general image of open and closed fold. And similar and parallel folds. So if you identify the similar and parallel folds are both are similar, but compared to that similar parallel folds, in the trough and crust side, in the parallel folds trough and crust side, so sharp edges will be identified. So that will be difference between similar and parallel fold. Here the similar folds will be lengthened, crust and trough, but here some sharpness will be identified. So that is the difference between similar and parallel folds. These are the folds will be identified in that different types of rock masses. So based on to that, whether the shape of the fold, it will be in the when you observe in the similar folds, the shape will be in the starting and crust and trough side and the anticline or syncline side. So the will be length and will be identified. So in the similar wise, parallel folds in the crust and trough and the anticline and syncline wise, the angular shape will be identified. So that will be called it as crust and trough will be always pointed to or angular to that. This will be called as a parallel folds. So these are the we are seen into already seen into that. So these will be crust and trough side, the angular will be identified, pointed or angular. So this will be always some length and thickness will be identified. So and overturned folds. So overturned folds are will be always overturned to that entire axial planes will be identified. So overturned folds are always overturned to that. So if will be identified, so both limbs are will be always overturned to that. So some vertical nature will be identified to that. So this will be called as overturned fold. So if you see, the overturned fold will be identified in that rock area, rock masses. So this is the overturned nature. So due to compressional forces acted on the particular rock body, the rock will be overturned. So then later on the positions will be seen into that this type of structure. So these are the general fold. So if you seen into that how the seen that entire area of rock, so how will be identified in that fold. And a chevron fold. So frequently we have to see in that different types of chevron fold. So when you observe in that rock different types of rocks, then the crust and trough are horizontal wise, vertically the sharp crust and sharp hinge will be crust will be identified, trough will be identified. So based on to that, so this is about to that chevron fold. So this we call it as, so when you seen in that any rock masses, so in that rock masses if you seen, so vertically if you identified sharp crust and sharp trough will be identified. This is the crust position. So this is the trough position. So these type of folds we have to see, we are identified in that different types of rocks. So these are called chevron fold. Chevron fold we call it as crust and trough will be some horizontally, some angular will be identified, sharp and angularity will be identified. So this will be called it as chevron fold. So and isoclinical folds. So isoclinical folds are limbs and axial plane always some horizontal will be identified. So if you seen this particular, so if you seen this particular image, so this is the one limb. So in that same way as axial plane also will be axial plane will be exact parallel to that limbs. So this will be called it as isoclinical fold. This will, so usually isoclinical folds are with reference to the limbs, so always will be parallel to the great extents will be identified. It will be called it as isoclinical folds. So this is the some example of isoclinical while we seen in the rock masses. And fan fold. So fan fold means in that so fan fold we call it as for example in the syncline nature. So in that trough side we towards to each other, the limbs will be towards to each other. This will be called as the limbs. So the limbs will be towards to each other. When will be crested, so this will be away from the each other. So it will be called it as a fan fold. So in that fan fold, when comes to the limbs. When comes to the limbs in the trough side, so the limbs will be towards each other. Towards each other. So when it comes to the crust side, so they away from the each other. So this will be identified into that fan fold. So when we see it as in the parallel fan fold, it will be fan shaped type trend will be identified, so it will be called it as a fan fold. So see in the fan fold, in that crust side it will be so towards each other the limbs in that anticlinal structure. In that trough side will be away from each other. So in that similarly, if you identify the syncline structure, in the similar pattern will be identified. So in that fan fold. So and another important type is that dome and basin. So dome and basins are two common features identified in that different places. So in the if you seen in the dome, so dome will be call it as a different cap-like structure. So in that dome, the older beds will be formed in the center of the rock area. So for example, this is the dome, we call it as to that. In that always in the upper projection, so younger beds will be formed. In the center point will be formed as older formation. In the similar wise basin, the opposite version we call it as the basin. So for example, this is the basin structure. In the center of the places, younger beds will be formed. The outer layer will be younger beds will be formed. So that is the difference between dome and basin. So for example, importance of dome and basins. So most of the basins will be identified different types of oil and gas productions. So for example, in the Krishna Godavari basin is the KG basin. Is the thick accumulation of gas and oil gases. We are able to see into that present day scenario. So this is the structure will be dome and basin. So in that in the dome, the older beds will be formed into that in the center. In the similar wise, it will be vice versa is the basin like the youngest formations will be in the youngest formation, the oldest formations will be formed as in that center. So this is the dome, oldest rocks will be formed in the center, while will be youngest formations will be formed as outer side. So this is the dome. So this is called as the basin. So always in the basin like structure, center beds will be formed in the center. So these are the younger beds formed as in the center. So vice versa in that dome and basin will be both are vice versa, whether it is the anticline wise and the syncline we call it as a basin. So gentle anticlines and gentle synclines. So whether it is a number of series of anticlines identified in that one particular rock mass, that is the gentle anticlines. A series of synclines will be identified in the one particular rock mass, that is the gentle synclines. So these are the magnitude, very large magnitude will be called as gentle anticlines and gentle synclines. So see, so these are the So these are we call it as a gentical synclines, magnitude wise very huge. They are identified. So these are the gentic anticlines. So magnitude wise very huge. So that's we call it as gentle anticlines and gentle synclines. So this is about the folds. So in this session we are able to know to that what is the definition of structural geology, and the strike, what is the strike and what is the dip, and the different types of folds we are able to know. In that coming the next session we are able to know to that different types of different parts of faults and the importance of civil engineering constructions we will learn in the next sessions. Thank you.